Algebra 2, Unit 2, Quadratics, Target C, Factoring Trinomials. All right, number 10 in the study guide says factor the following quadratic expressions. We're given x squared plus 2x minus 24. So the first thing you want to do is make sure that the trinomial you're given is in standard form, which would be ax squared plus bx plus c. Okay, now a is equal to 1, so we can do the shortcut that I taught you guys last week. So right away, you can go ahead and set up two sets of parentheses. Again, we're sort of doing 4 on reverse. The only way we're going to get x squared is if the first term in each parentheses is x. And then to find the two missing ones, you're going to want to do a shortened version of the ACB table that we did last time. Okay, a doesn't really matter in this case because multiplying anything by 1 is not really going to change anything. A is positive 1. C is negative 24. So when you multiply those together, you're going to get a negative 24. And B is positive 2. Okay, so keep in mind you want two numbers that multiply to give you AC, but when you add them together, give you B. So if you can't think of those two numbers right away, you want to consider the factors. 1 and 24. We have 2 and 12. 3 and 8. 4 and 6. Notice I'm not really taking into consideration the negative just yet. I just want to come up with factors that will give me 24. Now, I know B is positive 2. So 1 and 24 could never add up in any version to give me B, which is 2. 2 and 12 couldn't either. 3 and 8 are too far apart. 4 and 6 might. If I make 4 negative, that should work. So then that's negative 4 plus 6. Make sure it meets both conditions. Great. And then you're just filling in the blanks in both of the parentheses with the two numbers you found. So we can do minus 4, positive 6. Okay. This right here would be considered factor form, which according to directions is all we want. All right. I could say that quantity is equal to y. I could set it equal to 0. I could set it equal to f of x. It would be the same thing, but that's still factored form. All right. Now, if you want to do it the other method, which was grouping, which we started last week, I'll show you how to do that as well. So we still have the same quadratic, x squared plus 2x is minus 24, which is in standard form, ax squared plus bx plus c. Okay. Doing the same table, ACB. A was 1, C was negative 24. When we multiply them together, we get negative 24. B was a positive 2. We already found that the two numbers are going to be negative 4 times 6, which gives you a product of negative 24. And negative 4 plus positive 6 gives you a sum of 2. We would bring down the ax squared and the c value. And then we're going to want to break up the 2x using negative 4 and 6. Doesn't matter which order. So that'll be minus 4x plus 6x. Then looking at the first two, the only thing they have in common is an x. We're left with x minus 4. Looking at the next two, they're both divisible by 6, so we can factor that out, and we'll be left with x minus 4. Okay. Now we have a product here and a product here. Both of those have an x minus 4 in common, which I would factor out. I take it away from the left, I'm left with an x. If I take it away from the right, I'm left with a positive 6, which is the same factor form that we got in the previous one. Either way is acceptable. Obviously, the shortcut to the left saves us a couple steps. 11 has the same steps as before. It says factor the following quadratic expressions. The only thing I'll notice here, and hopefully you get to the point where you notice this too, x squared can be rewritten as the quantity x raised to the second. 64 can be rewritten as the quantity 8 raised to the second, and they're being subtracted. So what we have here is what we call a difference of squares, okay, which tells me that if we have some quantity squared minus some quantity squared, I can rewrite that as a plus b, a minus b. Okay, so in this case, I can go immediately to my two quantities. I know that the first one will be x, the second one will be 8, but I need a plus and minus so that when I multiply them, they would cancel out later. And this right here is factor form, which the directions say is exactly what we want. Okay, now let's say we go ahead and do it by grouping. That's possible. So we have x squared minus 64. We want it to be in standard form ax squared plus bx plus c. Notice it has an ax squared term and a c term, but it's missing bx. So you can enter bx in as 0x. And then if we go A, C, B, A is 1, C is negative 64. Multiply together, give me negative 64. B is 0. So we want some number that when we multiply them, two numbers, give me negative 64, but when I take their sum, give me 0. That's going to be negative 8 and positive 8. Okay. We bring down the ax squared. We bring down the c. We're going to rewrite 0x using a minus 8x plus 8x. Those two in front have an x in common. We'll be left with x minus 8. Those two have a positive 8 in common. We'd be left with the x minus 8. Okay, we have a product here and a product here. Both of those have an x minus 8 in common, so I would factor that out. Take it away from the left. I'm left with x. From the right, left with positive 8. And that is the same grouping method as before. You could also use a shortcut from the previous problem. So we have x squared minus 64, right? If I put 0x in for bx, we have x squared plus 0x minus 64. Again, because a is 1, that's super important, we can go immediately to parentheses. The only way we'll get x squared is if the first term in each is x. And then ACB method real quickly. AC multiplied together give me negative 64. B is 0. We already know the numbers to be negative 8 and positive 8. So then that would just be plus 8 minus 8. Doesn't really matter which one you put first. And notice in all three different ways, we get the same exact answer in factor form, which is what we were looking for. Okay, number 12, factor the following quadratic expression, same directions as 10 is 11. Notice A is not 1 here. A is a little bit bigger. So we want to see if we can factor out the GCF first between 6x squared, 32x, and 10. 6x squared and 32x both have an x, but 10 does not. 6 can be divided by 3, but 32 and 10 cannot. 6 can also be divided by 6, but 32 and 10 cannot. 6 can also be divided by 2, and it looks like 6, 32, and 10 all can be divided by 2. So we'll factor out a 2. Okay. Take it away from 6x squared, we'd be left with 3x squared. Factor out a 2 from 32x, we'll be left with a positive 16x. Factor a 2 out from 10, and we're going to be left with a positive 5. Okay. And then this 2 will still be part of our answer. I'll just put an arrow down to remind me to bring it down. Now I can focus on the trinomial within the parentheses using the grouping method. So we'll go ACB. A is 3. C is 5. 3 times 5 gives me 15. B is a positive 16. So I want two numbers that when I multiply give me 15, but when I add the same two numbers, it gives me 16. We have 1 and 15, 3 and 5, and those are the only factors of 15. 3 and 5 can never combine to give me 16, but 1 and 15 will. So 1 and 15 are my numbers. I'm going to bring down the ax squared. I'm going to bring down the c. I'm going to break down 16x using 1 and 15, plus 1x plus 15x. Looking at those two, the only thing they have in common is an x. We'd be left with 3x plus 1. 15x and 5 both have a positive 5 in common. We'd be left with 3x plus 1. Okay. The 2 from before, I'll go ahead and finally bring that down. These two both have a 3x plus 1 in common, so I'll factor that out. Factor it out from the left, we're left with an x. Factor it away from the right, we're left with a positive 5. And directions were just to factor, so this right here, 2 times the quantity 3x plus 1 times the quantity x plus 5 is my final answer. Keep in mind, because a was not 1, this is really the method to go about it. It's called grouping because we group factors and like terms together. Okay. Now, let's say we didn't factor out the GCF. We strongly should, but if we hadn't, okay, let's go with 6x squared plus 32x plus 10. Let's say we didn't identify the GCF at first. If we use the same grouping method, A is 6, C is 10, multiply those together, you would get 60, B is 32. So we want two numbers that multiply to give me 60, but add up to 32. We have 1 and 60, we have 2 and 30, we have 3 and 20. We have 4 and 15. We have 5 and 12. 6 and 10. And I believe that would be all of them. 1 and 60 could never give me 32. 230 might. 320 wouldn't. 415 wouldn't. 512 wouldn't. 610 wouldn't. Looks like it'd be 2 plus 30. All right, so we bring down the 6x squared. We bring down the positive 10. We rewrite 32x as positive 2x and positive 30x. Now keep in mind for all these that we do by grouping, if you rearrange the middle term and you put, let's say in this case, I put 2x and then 30x. If you switched it around, our work would look a little bit different, but our final factor answer should be exactly the same. Okay. Between those two, looks like there's a 2x in common. We'd be left with 3x plus 1. Between 30x and 10, we can factor out a 10. We'd be left with 3x plus 1. These two are being multiplied. These two are being multiplied. What they have in common is a 3x plus 1. Factor it out from the left. We're left with 2x. Factor it away from the right. We're left with a positive 10. Now, technically, this is factor form, but it's not in its most simplified factor form. I know I mentioned it in class last time that I would accept it this way. However, because it's not in its most simplest form, we should break it up a little bit further. 3x and 1 have no GCF in common. 2x and 10 are both divisible by 2, so we could take a 2 out. The first quantity, 3x plus 1, would still stay there. If we factor out a 2 from 2x, we'd be left with x. If we factor it out from 10, we're left with a positive 5, which would then give us the same thing. Now keep in mind, if we wanted to, we could also write it like this. And it'd be the same thing. When it comes to multiplication, it doesn't matter the order of the factors. We would still get the same products. All right, number 13 says solve the following equations by factoring. And then at the bottom, they want us to write out the factor form and then the solutions. Okay. So first thing we want to make sure is that our quadratic is in factored form. It is not. Ax squared plus bx are on the left, but the constant c is on the right. So I want to get rid of this positive 21 by subtracting it from both sides. Okay, so we have 2x squared minus 11x minus 21 is equal to 0. That now is factored form. Okay, a is not 1. So we're going to have to do grouping. So we checked if it's in standard form. We corrected that. Now we're looking for a GCF. 2x squared and 11x both have an x, but 21 doesn't. 2 can be divided by 2, but 11x and 21 cannot. So there's nothing that all three terms share. So then we can go ahead and create our little table, A, C, B. A is 2, C is negative 21. You multiply those together, and you should get a negative 42. B is negative 11. So we want two numbers that when we multiply them give me AC, but when I add them give me B. So we have 1 and 42. We have 2 and 24. 3 and 14. Not divisible by 4, not divisible by 5, 6, and 7. Okay. Notice if you don't know your multiplication facts, you could just take the product 42 and divide it by a number you think it might work. So like if you weren't sure 42 can be rewritten as 3 times something, just take 42 divided by 3 and you would get 14. And that's how you can get your factors as well. 1 and 42 can never give me 11. 2 and 24 are too far apart. 3 and 14 might. 6 and 7 would not either. So 3 and 14 are probably going to be our numbers. However, we need a negative product and a negative sum. So that tells me the bigger number should be negative. So 3 times negative 14 gives me negative 42. 3 plus negative 14 gives me a negative 11. Okay. Bringing down the ax squared, bringing down the c. You can leave it set equal to 0. We're going to need that regardless later. We're going to break up minus 11x using positive 3x and minus 14x. 2x squared plus 3x both have an x in common. We'd be left with 2x plus 3. Negative 14 and negative 21 both have a 7 in common. Keep in mind, though, because we want the parentheses to be the same, it makes sense to factor out a negative so that we're left with 2x plus 3 inside. These two are product. These two are a product. They both have a 2x plus 3 in common. Take it away from the left. We're left with x. Factor it out from the right. We're left with the minus 7. That right there will be factored form. So I'll pause right now and fill this blank out. the quantity 2x plus 3 times the quantity x minus 7. You can set it equal to 0 or not. It would still be okay for factor form. And then for solutions, we want to take it one step further. Just going to go ahead and put it to my right for a little bit more space. We're going to want to set each quantity equal to 0, right? Because if I'm telling you that this quantity that times this quantity is equal to 0, one of them must be 0. Or x minus 7 is equal to 0. Subtract 3 from both sides. We're left with 2x is equal to negative 3. Divide both sides by 2. We're left with x is equal to negative 3 halves. Okay, and this one just adds 7 to both sides. We're left with x is equal to positive 7. So my solutions are x equals negative 3 halves and x is equal to 7. All right, number 14, same direction, solve the following equations by factoring. Okay, so we want to make sure first that it's an ax squared plus bx plus c format. It is missing a bx, but it is in standard form. Off the top of my head too, I'm thinking 9x squared can be rewritten as a quantity 3x squared. 25 can be rewritten as a quantity 5 squared. It's a difference, so this is a difference of squares. Which again, if you have a quantity squared minus a quantity squared, you can write it as a plus b times a minus b. So that would give me two parentheses right away. This would be the first term in each. This would be the last term in each. And I need a positive and a minus version of it. That right there is factor form. So I'm going to go ahead and put that down here. 3x plus 5 times the quantity 3x minus 5 is equal to 0. Now I need to go ahead and solve it. So I'm going to say each one equal to 0 because I'm saying if this one times this one equals 0, one of them must be 0 to give me a product of 0. So we have 3x plus 5 is equal to 0, or 3x minus 5 is equal to 0. Subtract 5 from both sides. We have 3x is equal to negative 5. Divide both sides by 3. You have x is equal to negative 5/3. Cannot be simplified any further. On the right, add 5 to both sides. You get 3x is equal to 5. Divide both sides by 3. You get x is equal to a positive 5/3. So solutions, x equals a negative 5/3. And x is equal to a positive 5/3. Now, let's say we didn't realize it was a difference of square. We could still do this. So we have 9x squared minus 25 is equal to 0. We notice it was missing a bx, so we can set that equal to 0. Okay, we can go ahead and use the ACB. A is 9, B is a negative 25. Okay, so what we're going to want to go do is multiply those two together to see what they give me as a product. So we have 9 times a negative 25 is going to give us a negative 225, and our B is 0. Okay, now you can not waste time, but you can take up a lot of time trying to come up with all the factors of 225. I'm sure there's a handful of them. But keep in mind, we basically want whatever two numbers we choose to be the same, but opposite sign, so that when I add them, I go ahead and I get 0. So you could just take the square root of 225, forget the negative, and that would give you 15. And one of them has to be negative. So just a quick little shortcut when you're dealing with difference of squares. Okay. Or if you're dealing with a b value that's 0, you know that the numbers have to be the same but opposite signs to cancel out. So we'll bring down ax squared, we'll bring down c, and then we'll use positive 15x minus 15x to rewrite 0x. Look at the first two. Those both have a 3x in common. We would be left with 3x plus 5. Negative 15x minus 25 can both be divided by 5. We also want to factor out a negative so that the quantity inside the parenthesis remains positive. That'll leave me with 3x plus 5. Here's a product. Here's a product. They both have 3x plus 5 in common. Factor it out from the left. We have 3x. Factor it out from the right. We have a minus 5 is equal to 0. And then from there, the work to solving it would be identical. Okay, so you don't need to use both methods on the test to show me, but just realize that both methods are feasible. I think the one on the left, when you identify difference of squares, does save you a little bit of work. All right, number 15 says find the zeros of the function by factoring. That just means we have to solve it. We want to look for the x-intercepts, right? F of x is the same thing as y. You can also set it equal to 0. Not a big deal. Right now, I'm just going to focus on the first step. Ax squared plus bx plus c. Looks like it is in standard form. I want to see if it has a GCF. It does. A -5 can be factored out. Okay. If you factor it out from -5x squared, you would be left with just x squared. You factor it out from 50x, you'd be left with minus 10x. Factor it out from a minus 80, you'd be left with a positive 16. And then from there, a, c, and b. A would be 1. C would be a positive 16, which multiply to give me 16. And b is a -10. Okay. Factors of 16, 1 and 16, 2 and 8, 4 and 4. 1 and 16 could not give me 10. 4 and 4 could not either. 2 and 8 could, as long as I make them both negatives. -2 times -8 gives me a positive 16. And -2 plus -8 gives me a -10. Okay. Error on -5, that'll be part of my answer later. But I don't need it as of the moment currently. So bring down ax squared. Bring down c. And we're going to rewrite -10x as minus 2x minus 8x. Those two first terms have an x in common. We factor that out. We're left with x minus 2. -8x plus 16 both have a 8 in common, and we're going to factor out a negative so that the signs change like we want inside. We'd be left with, x minus 2. Okay. This product and this product both have an x minus 2 in common that we can factor that out. We factor it out from the left, we're left with x. Factor it out from the right, we're left with the minus 8. This right here is factored form. Okay. We want to find the zeros, which means we want to take it one step further and solve. So we set it equal to 0. I'm telling you that this times this is equal to 0. So either the first one is equal to 0 or the second one must be. And let me pause there because I forgot a crucial step. We forgot to bring down, I forgot to bring down the -5. That right there is factored form. Without the -5, that would be incorrect. Okay. Now, notice when it comes to solving, I don't set -5 equal to 0, and that's because -5 equals 0 would give me a false statement. Also, -5 doesn't contain a variable, so there would be no need to set that factor equal to 0. All right, continue solving. We want to add 2 to both sides. We get x is equal to 2. Add 8 to both sides. We would get x is equal to 8. So find the zeros. X equals 2, and x equals 8. All right, number 16 says factor and solve the following quadratic equation. Okay. So looks like it is in standard form, ax squared plus bx plus c. The only thing here is there is no c value. Not a big deal. We can quickly factor this one by factoring out the GCF. They both have a 3x in common. If I factor that from 12x squared, I would be left with 4x. Factor it out from minus 3x, we'd be left with just a minus 1. That right there would be my factored form. Okay. Now, in order to go ahead and solve it, I'm just going to take it one step further, set it equal to 0. Now, we're going to do 3x is equal to 0 and 4x minus 1 because both of those factors contain an x. So 3x is equal to 0 or 4x minus 1 was equal to 0. On the left, all we got to do is divide both sides by 3. Turns out x is equal to 0. On the right, we're going to add 1 to both sides first. That gives us 4x is equal to 1. Divide both sides by 4. Turns out x is equal to 1/4 would be my other solution. Okay. Now, we could also do it this way. I'm just going to throw this out there in case you want to do it this way. We had 12x squared minus 3x. And we notice that there is no c. So you could put a plus or minus 0 in its place. Doesn't really matter. Let's do a c. A is 12. C is 0. So we multiply those, we get 0. B is a -3. So we want two numbers that multiply to give me 0, but add up to give me a -3. Okay. This one's where it becomes a little bit trickier. Because we want the sum to be -3, the numbers have to be 0 and negative 3. And that's tricky to understand, but it'd be the only way that I could get a sum. Obviously, any combination of numbers can give you 0, but because we want the same numbers to add up to give you negative 3, one of them has to be negative 3. So then here, we're going to bring down ax squared. We're going to bring down c. And this one, it makes more sense to put the minus 3x first and the 0x later. Okay, and you could put the 0x as positive or minus. It's not really going to change or make a difference. First two here have a 3x in common. We'd be left with 4x minus 1, which notice is the same thing here. That's why it makes more sense to use this method to the right than the one on the left. And then in theory, on the right, you could factor out a 0 and you'd be left with x. See, this one I don't like because factoring out technically means you're dividing by 0, and we're not supposed to. So like the second part of this would be considered null or void. It wouldn't be necessary to continue. And then from here, we'd be left with the same thing as over there. So for this one, I would strongly recommend not using grouping and using the method to the right, just factoring out the GCF right away.